Welcome back. So we are mastering the technique of nodal analysis, and we have solved multiple circuits that involves basically a supernode now and dependent sources. So this is the next example of this series where we are basically going to solve a circuits that have a current controlled voltage source that is connected between the nodes V1 and V2 like here, right? This is a current controlled voltage source. And the target of this question is to find the values of Ix, V1 and V2. So what is Ix? Ix is basically nothing, the current through 2 kilo ohm. What will be that? V1 minus 0 divided by 2k, right? So we can write the controlled equation for the variable that we need to find. So the second thing is to find the value of V1. What is V1? Okay, the voltage here that we can find using nodal. V2 voltage here that we can find using nodal. Okay, so because this current control voltage source is connected between two nodes, okay, so we can and this makes basically a supernode, so we can write the equation for the supernode here. Okay, so what will be that equation? That will be V2 minus V1. Why V2 minus V1? Because this is a positive sign here. So V2 minus V1 is equal to 2000 of Ix. Okay, this is our supernode equation. So what is Ix? Ix, we know that V1 over 2k. So let's put that here. So 2000 Ix is V1 over 2k. Always like whenever there is a dependent current or voltage source, so you need to put up the control variable equation and put that in actual equation, and that will just simplify that. So 2k is nothing, 2k is 2000, so 2000 and 2000 cancelled out, so we are left with basically nothing, V1, right? So this V1 can go to the other side, so that will become minus 2V1 plus V2 is equal to 0, right? So this is our first equation, the simplified form of the supernode equation. Now second, let's try to write the current equations. Okay, actually the nodal equation. So the current deriving from V1, that is this one and this one. So we can write basically minus 4 milli plus the current through 2k. What is that? V1 minus 0 divided by 2k. Then current with reference to V2, leaving current, so that is 2 milli plus the current through 2k. What is that? V2 minus 0 divided by 2k is equal to 0, right? So let's simplify this by just multiplying with 2k. So minus 4 times 2 minus 8, k and milli cancelled, 2k cancelled, plus v1, 2 times 2 4, milli and k cancelled, 2k cancelled, plus v2 is equal to 0. So we have v1 plus v2 minus 8 plus 4 minus 4, it will go to the other side, it will become 4. So two equations, two unknown. Okay, so what we can substitute, for example here I can say that v1 is basically 4 minus v2. Again, like this is just a one substitution, you can go other way around also. So let's put that in equation 1. Okay, where is equation 1? So what will it become? Minus 2 times of v1 is basically 4 minus v2 plus v2 is equal to 0, or minus 8. Okay, 2 times 4 8, minus minus plus 2 times of v2 plus v2 is equal to 0, or I can say that v2 is nothing, just 8 over 3 volt. Okay, and this found value I can put okay here, okay, to get the v1. So what is v1? 4 minus v2, v2 is 8 over 3. Okay, so 8 over 3 is basically what? 24 minus 8, 16 over 3, right? Volt. Okay, so this is the value of v1 here. Okay, 16 over 3. So we have value of v1 and v2. Now we can use these values to get the desired one. So our target was basically to get V1. So V1 comes out to be 16/3, V2 comes out to be 8/3, and we are left with Ix. What was Ix? We have already written the equation, control equation for this one. Ix is V1/2k. So let's plug in the values. So Ix will be V1 is 16/3 divided by 2k. So 2 and 8. So we will have 8/3 milliampere. So this is the value of Ix. Okay, this way we can find the desired values for this given circuit. Thank you.